Hi everybody, in this video let's look at 1.4 Applications of Circular Measures. In this part we do not learn any new formula, we just need to know how to use the knowledge that we learned before to help us to solve some questions. Okay, let's do a quick revision. The first thing we learned in this chapter is the conversions between radian and degree. Okay, pi radians equal to 180 degrees. Pi is just 3.14 something. So from here you know that from radian to degree the number becomes bigger, right? From degree to radian the number becomes smaller. So if I ask you to convert an angle in radian to degree, you know that the number becomes bigger, right? So you have to put the bigger number on the top times 180 over pi. If I ask you to convert an angle in degree to radian, the number becomes smaller. You have to put the small number on the top times pi over 180. This is the first thing that we learned in this chapter. Okay, second thing we learn about how to find the arc length, right? So if I want you to find the arc length AB, the formula is R theta. The theta must be in radian. Okay, so next we learn about how to find the perimeter of a segment, right? Perimeter of a segment. So the perimeter of a segment is actually the sum of the arc length and the chord length, right? So the arc length is R theta. The theta here must be in radian, plus the chord length. So the chord length is 2r sine theta over 2. So the theta here can be in radian or degree. If this is in radian, when you key in your calculator, you have to be more careful. So this is arc length, this is chord length. Okay, so next we learn about the area of a sector. The area of a sector is 1 over 2 r squared theta. This theta must be in radian. Okay, last we learn about area of a segment. So if you want to find the area of a segment, we know that we have to take the area of a sector minus the area of this triangle, right? So that we can get the area of the segment, shaded segment here. Area of the sector is 1 over 2 r squared theta. We have to minus the area of the triangle over here. So this part, okay, let me show it for you. This triangle, because we don't want this part, we only want this part, right? So we have to minus the area of a triangle. How to find the area of the triangle? 1 over 2 r squared sine theta. So this is the area of a triangle, this is the area of the sectors. We take this one minus this one, then we will get the area of the segment here. Okay, now let's try few questions. In a creative art class, students are learned to how to make hand fan. Each student is given a piece of color paper that has been cut. Then the paper is folded into, okay, this typing error, into few equal parts. The area of each part is 18.4 square centimeters. Diagram above shows a sample of hand fan that has been made. Find the number of folded parts. It means that now I don't know how many parts I can fold here. Let me draw a simple diagram for you. Oops. So every part here, they have the same area, which is 18.4 square centimeters. So now I have n part. So maybe 20 part, 40 part, I don't know. I want to find the value of n, find the number of folded part. Okay, so I have n part, right? So it means that 18.4 times n. When you take 18.4 times n, you get the total area for this paper, correct? So now I want to find the area for this part. Okay, this part. Okay, I want to find the area here. So how do I get the area here? I need to find the area of this sector here minus the area for this smaller sector. Okay, now let's focus on the big sector first. What is the formula? 1 over 2, let me use back the pink color. 1 over 2 r square, the r is 20. Okay, the r is 20. 1 over 2 r square theta, the theta is 2.6211. 2.6211. Okay, 1 over 2 r square theta. This will give us the area. Okay, okay, so if this part, what we get from here is the area for this entire sector here. But we are not looking for this one, right? We only want the area for the paper part. So we have to minus. We need to minus this part. We don't want this part. So I have to minus 1 over 2. This time we have to use this r. Okay, so here is 20 and this is 13. We know that from here to here is 7 centimeters. I take 20 minus 13, I get 7 centimeters. So the r here is 7. 1 over 2 r squared theta. Theta is still the same because the angle here is still the same, right? 2.6211. Okay, so when I take this minus this one, I will get the area of the paper. So next, you just press your calculator. So this, you just copy first, 18.4 n. 0.5 times 20 square time. Okay, this is 524.22. Okay, how about this? 1 over 2. If you don't want to press 1 over 2, you can just key in 0.5. 7 square time. Okay, very long decimal places, 64.21695. If you don't want to write so many decimal places, you can just round off your answer to 64.22. Okay, so if you want to take all the decimal places, is okay. Now, 524.22 minus 64.22. I will get 460 over here. So this is still the same, 18.4 times n. How do I get the n? I take 460 divided by 18.4. So the n is the number of folded part. Okay, so the answer is 25. Okay, let's try one more questions. The diagram above shows the plans of a recreational centers OAEB. Okay, OAEB is a semicircle with center O and its diameter is 24 meters. 24 meters. Diameter, it means from A to B. So it means that the radius is 12 meters. Okay, here is 12, here is 12. Okay, so OGF is a sector of a circle. Where is OGF? OGF is a sector of a circle with the center O, and OA to AG is 3 is a 2 ratio. So OA, here we take 3 parts. So here we take okay, let me check again. OA and AG. Okay, this is 2 part. This is 2 part. Sector CDB. CDB. This is children playground. Okay, let me label it. This is children playground. And C is a midpoint of OB. C is a midpoint. So here it's 12, right? So C is a midpoint. It means that here 6 meter, here 6 meter. Okay. So the shaded regions is the parking lot. So this is parking lot. Okay. And has to be gated. Has to be gated. We want to fence up this part. Given that CD is parallel to OE. CD is parallel to OE. So let me put this symbol so that we know these two are parallel to each other. Okay, an angle DCB, this is 145 degrees. Calculate the area in square meters of the children playground. Children playground is over here. So we want to find the area of this sector. This is in degree. If you don't want to convert to radian, you can just use the formula that you learned before, pi r squared times theta over 360. Okay, let me show you both. First, I'm going to show you how to use the formula that we just learned in this chapter, which is 1 over 2 r squared theta. If I use this formula to find the area, the theta must be in radian. So first thing, I want to convert this angle to radian first. 145 degrees is equal to how many radian? Degree to radian, number becomes smaller, right? So time pi over 180. It will be converted to radian. Okay, just press our calculator. So the question asks us to use pi as 3.142. So we just, when we key in the calculator, just put 3.142 over here. So how about I change this one to, okay, let me add one more step for you. 3.142 over 180. So this is radian. 145 times 3.142, something is 180. Okay, 2.5311 radian. Okay, so this is the angle. This is the angle in radian. So we can start to use this formula to help us get the area. So area of children playground is equal to 1 over 2 r squared r 6. Theta must be in radian, which is 2.5311. Okay, so well, long decimal, we can just give answer in correct to 4 significant figures, which is 45.56 square centimeters. So let's say if you don't want to use this formula, you can use another formula which you learned before. Okay, pi r squared, pi r I6 pi r squared times theta over 360, right? So this theta will be in degree, which is 145 over 360. Okay, just press your calculator. This is 360. You still get the same thing, 45.56 square centimeters. Okay, now let's try part B. Okay, part B, the length in meters of the gate required for the parking lot. It means that we want to find the parameters over here. This, plus this, plus this, and this. Okay, we want to fence up this parking lot. So we want to find the parameters. you know that if you want to find the arc length here and here, you need the data over here, right? So the data here is very easy because the question tells you that these two straight lines, they are parallel to each other, right? So this, just now we have converted it to radian, which is 2.5311 radian. So if you want to get this part, you just take pi minus this one, 3.142 minus 2.5311. Okay, which is 0.6109. So it means that this part is 0.6109 radian. Here the same thing because they are parallel to each other. 0.6109 radian. Okay, now we got the angle here, theta here, but to find this arc length, no problem. We can use the r theta. This is the r. This is theta. To find this one, FG, we need the r over here. The r is over here from G to O, but the problem is we don't know the length of AG. Okay, now we can think this way: 3 parts is equal to 12, right? So 2 parts equal to what is the length? This is just a ratio, so you can do it this way: AG, you take 12 divided by 3, so that you know one part represents how many meters. So here we take 2 parts, you have to times 2. This is equal to 8 meters. Now we know that AG or GA is equal to 8 meters. Okay, so now we can start to find the arc length. I think I do it separately, so clearer, it's easier for you to understand. Arc length AE equal to r theta. So the r is 12, theta is 0.6109. Okay. .3308 meters. So how about the arc length of FG? GF. FG. Okay, I write F first. FG. Same thing, r theta, but this time we are not using 12 as a r, but the r is 20. 8 plus 12, which is equal to 20. R theta, sorry, the theta is still the same thing, 0.6109. Okay, 20 times 0.6109, 12.218 meters. Okay, now we can proceed to the last step, the length, the total length. The total length of the gate required. You can write the total length of gate required. If you don't want, you just write the total length, it's okay. Okay, so we have to take this, which is 7.3308 plus this one, which is 12.218, and plus 8 and 8, right? 2 times of 8. Okay. Chỉ点3308. Okay, so I just correct it to 4 significant figures, which is equal to 35.55 meters. Okay, so this is the way how we solve this type of questions. Let's try the last part. Part C. The area in square meters of the parking lot. We want to find the area here. So you know that if you want to find the area here, the shaded part, you take the area of this sector OFG minus the area of the sector OEA, right? Okay, so area of parking lot is equal to 1 over 2 r square theta. 1 over 2 r square, 20 square, 1 over 2 r square theta, this 0.6109. This part will give us the area of OFG. Okay, but we don't want OFG. We only want this shaded region. So we have to minus the area for OEA. So same, using the same formula, 1 over 2 r square, but this time the r is not 20 but 12 only. 1 over 2 r square theta. Okay. This is 12 point, oops, sorry, not 12. 122, 122, okay, 122.18 minus this is so this is 43.9848. Okay, if you want to, you can take all the decimal places. If you don't want, you just round off it to 4 significant figures. So since this is not very long decimal places, I take all, so it will be more accurate. 122.18 minus 43.9848. Okay, for the final answers, we just round off it to 4 significant figures, which is 78.20. Okay, so this is the final answer for this part. That's all for this video. Thanks for watching and see you next time. So if you don't mind, if you feel that my video is helpful, make you understand better, you can help me to share with your friends who also need this type of video, especially for the students who are not afford to attend tuition class. Okay, thanks for your help. See you next time. Bye bye.